Hey guys, welcome to your Chapter 9 practice test. We're going to go over everything from Chapter 9 right now as we go through this practice test together, and hopefully that'll help prepare you for hopefully you're already prepared, but this is like one last shot to get 100% prepared for your Chapter 9 test, which is tomorrow. So make sure you pay attention carefully and do all the work on your scratch paper with me as we go through this Chapter 9 practice test together. So you should have your scratch paper out with you and obviously something to write with, and you should have this video opened on one side of your screen and then split your screen and open up the Chapter 9 practice test on the other side so that we can do it together. Okay. As we go through any test, we want to make sure we follow our 3 testing success guidelines, which is read every question carefully. That means at least 3 times. And then use scratch paper for every single problem except for vocabulary questions. And then go back over all of your work. Question 1 is fractions that have the same denominator, such as 1/3 and 2/3 are. And this is a vocabulary question, so we don't have to use our scratch paper. The answer is like fractions. Like fractions are fractions that have the same denominator. Since both of these fractions have the denominator of 3, they are like fractions. They're not equivalent fractions. Equivalent fractions are fractions that have the same value. Like fractions are fractions that have the same denominator. Next, fractions that have the same value, such as 1/4 and 2/8. So these are 2 different fractions, but they represent the same amount. If you ate 1/4 of a pizza and your friend ate 2/8 of a pizza, you both ate the same amount. Your 1 slice was the same size as his 2 slices. So these are equivalent fractions. Notice the word equal. You can almost hear the word equal in the word equivalent. That's because it means fractions that are equal to each other. Next, the blank of 5/6 and 7/12 is 12. It's the least common denominator. Even though this is a vocabulary question, I'm still going to put something on my scratch paper here. Why is the least common denominator of 5/6 and 7/12 12? Because if we list the multiples for the denominator 6 and 12, so that means we count by 6s and we count by 12. 6, 12. The second multiple of 6 is 12, and the first multiple of 4 is 12, which shows that the least common multiple, the smallest multiple that 6 and 12 share in common, is 12. And we could use that to make an equivalent fraction with 5/6. 6 times 2 is 12. 5 times 2 is 10. Now, 10/12 is the same value as 5/6, but it's a like fraction with 7/12. And that would make us able to compare it with 7/12, or we could add it to 7/12, or we could subtract 7/12 from it. Now we can do operations with these 2 fractions because they have the same denominator. They're like fractions now. So that is least common denominator. Next, a number that has a whole number part and a fraction part. That's a mixed number. An example of that is like 2 and 1/2. That's a mixed number because it has the whole number 2, it has the whole number part, and it has the fraction 1/2, the fraction part 2 and 1/2. That's a mixed number. It's mixed because it's a mix between a whole number and a fraction. It's both at the same time. 1/8 and 3/4 are blank fractions because their denominators are not the same. So what do we call fractions that don't have the same denominator? They're not like fractions, they're unlike fractions. Anytime fractions have different denominators, they're unlike fractions. Now, fractions that have different denominators could also be equivalent fractions, but these aren't equivalent fractions. And the question is, 1/8 and 3/4 are blank fractions because their denominators are not the same. So even if they were equivalent, this would not be the answer because they're unlike because the denominators are not the same. If they were equivalent, they wouldn't be equivalent because they had different denominators. But they are unlike fractions because of the fact that that 1/8 denominator is 8 and 3/4 denominator is 4. Those are different denominators, so they're unlike fractions. They're not like each other. It means you can't work with them. You have to give them like denominators before you can add them, subtract them, or compare them. 7/5 is a or an blank because its numerator is bigger than its denominator. What do you call that when a fraction has a numerator? See 7/5 here? 7 is bigger than 5. Its numerator is bigger than its denominator. Its head is too big. We call that an improper fraction. It's not proper. It's not properly written. This isn't the right way to show this value. The right way to show 7/5, see, anytime a fraction has a numerator that's bigger than its denominator, it means it's more than 1. And a fraction is supposed to show a value that's less than 1 because it shows something out of something, less than the whole thing. But if you have 7 out of 5, that means you have all 5 marbles, or whatever it is, all 5 slices of pizza, plus more. That means you have more than one whole. And the way we change this into, sometimes it's a whole number, sometimes it's a mixed number, in this case it'll be a mixed number, is by dividing the denominator into the numerator. So we divide 5 into 7, it can fit in one time. Then we multiply, 1 times 5 is 5. Then we subtract, 7 minus 5 is 2. Whatever our denominator is, that becomes the new numerator of our fraction. And whatever our divisor is, that's our denominator. And another way of saying that is that the denominator just stays the same because it was already 5. And so the proper way to write 7/5 is 1 2/5. One whole and then apart 2/5. That's called an improper fraction when it's written this way instead of this way. So really, an improper fraction is just a fraction that should be written as a mixed number or a whole number. Round 5/7 to 0, 1/2, or 1. So the fact that 5 is more than half of 7 means we round it up to 1. Because if you had 5 out of 7 slices of a pizza, you have almost a whole pizza. You're only 2 slices short. Next, 9/10, round to 0, 1/2, or 1. If you had 9 out of 10 slices of pizza and your friend called and said, hey, how much pizza is there? Would you say, oh man, we have pretty much 0? No, because you have almost a whole pizza. Would you say, oh, there's about half a pizza left? No, you're only 1 slice short of having a full pizza. Or would you say, we have pretty much a whole pizza left? Yeah, if you were eating the very first slice out of that pizza, you wouldn't be like, oh, there's pretty much no pizza left, because there's the whole pizza left except for the 1 slice that you just took. That's what this is. You have all but 1 slice of the pizza. You have 9 out of 10 slices, so you would round that up to 1 whole. Next, round 1/9 to 0, 1/2, or 1. If you had only 1 out of 9 slices of pizza left, you have a pizza cut into 9 slices, and you have 1 of those slices left, and your friend calls and he's like, hey, how much pizza is there? You wouldn't be like, we have almost a whole pizza left, dude. Come on over. No, there's only 1 piece left. Your friend's going to be really disappointed when he gets there. And maybe it'll be gone by the time he gets there. And then you wouldn't say, we have like half a pizza left. No, you only have 1 out of 9 slices. You would be like, there's pretty much no pizza left. I mean, there's 1 slice, but you wouldn't want to come over just for that. So it rounds to 0. Round 5/11 to 1, 1/2, or it's supposed to say to 0, 1/2, or 1. It says 1, 1/2, or 1. So that's supposed to be a 0 there. I'll fix that before you actually take this. So when you open it up, you'll see a 0 right there. Would 5/11 round to 1, 1/2, to 0, 1/2, or 1? So if we showed 5/11, let's say we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 marbles. What does half of those marbles look like? Well, 1, 2, 3, 4, 5. And then we have 5 there, and we have 1, 2, 3, 4, 5 here. So half the marbles would be halfway between this marble. Okay. Now we have 5 out of the 11. So we have this one, this one, this one, this one, and this one. Do we have almost half? Yeah, we're only half a marble short of half of the entire set of marbles. So would we say we have just about half the marbles? Yeah. So that rounds to a half. Okay, next, this is where we're really going to use our scratch paper. I'm going to box off everything I just did into one section. And this is where we're really going to start using our scratch paper. This is where it really counts. Okay, 5/9 plus 1/9. You would definitely want to put this on your scratch paper. You would not want to try to solve it in your head, even though you could. That's not good practice. You put everything that requires solving, you put down on your scratch paper, even if you know you can easily do it in your head, because you're more likely to make a mistake in your head than you are on your scratch paper. So even easy problems, if it requires any solving at all, write that solving down. 5 plus 1 is 6, and the denominator 9 stays the same. Now, 6/9. Are there going to be common factors between 6 and 9? The answer is yes, there is. But anytime you're not sure, you should just try to simplify it. See what happens if you list all the factors. All the factors of 6 are 1, 2, 3, and 6. 1 times 6 is 6, 2 times 2 is 6. All the factors of 9 are 1, 3, and 9. 1 times 9 is 9, and 3 times 3 is 9. We can see the GCF is 3, so it does need to be simplified because it has a GCF greater than 1. We divide the numerator and denominator by that GCF. 6 divided by 3 is 2. 9 divided by 3 is 3. So the answer is 2/3. Notice 6/9 isn't even here as an available answer. And so that's always a good hint that you do have to simplify it if your answer isn't even here. The answer is 2/3. 5/9 plus 1/9 simplified, put in simplest form, is 2/3. Next, we have 6/7. We're going to box this off. That's the work we did for that problem. And now we're going to solve this one right here. 6/7 plus 1/7. Okay, we add our numerators together. 6 plus 1 is 7, and the denominator 7 stays the same, 7/7. Now, this is a special kind of improper fraction called a whole fraction, where the numerator and the denominator are the same. It is still improper because it does need to be changed into a whole number. And anytime your numerator and your denominator are the same, the fraction equals 1. Anytime. If it's 6/6, 3/3, 2/2, 10/10, whatever it is, if your numerator and denominator are the same, the fraction always equals 1. So the answer to number 10 is 1. We're going to box that off and move on to our next question. 5/8 plus 1/8. We put it down on our scratch paper. 5/8 plus 1/8. We add our numerators together. 5 plus 1 is 6, and the denominator 8 stays the same. Now, can this be simplified? Anytime both the numerator and denominator are even numbers, you know they can be simplified. And in this case, the GCF would be 2. So, and I'm just trying to save time right now by not listing out all of the factors, but you would want to do that. List all the factors of 6, list all the factors of 8 until you find the GCF. In this case, the GCF is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. The final answer is 3/4. Okay, next one. 3/5 plus 1/10. Now this one's a little harder. They don't have common denominators. So instead of writing it long ways, I'm going to stack it. Why would I want to stack it this time? Because I'm going to have to find the least common denominator. I'm going to have to make these fractions like fractions before I can add this together. So I stack it so I can make my equivalent fractions to the side of them. And I can already see 10 is going to be the least common multiple for 5 and 10, because I know if I count by 5s, I'm going to get to 10. 5, 10. So I'm going to make 10 my least common denominator, which means I don't have to change this fraction. I only have to change this one. 5 times 2 is 10. Whatever I do to the bottom, I have to do to the top. 3 times 2 is 6. So now 6/10 is an equivalent fraction with 3/5. It means the same thing, but it's a like fraction with 1/10. So I can add these together now. and I add my numerator. 6 plus 1 is 7, and my denominator 10 stays the same. The answer is 7/10. Since 7 is prime and it can't divide evenly into 10, I know this fraction cannot be simplified. So the answer is 7/10. Okay, moving on, we have 1/2 plus 1/8. This is another one that I'm going to stack because I know I'm going to have to find common denominators. And I know if I count by twos, I'm going to get to 8. So I know 8 has to be the least common multiple. So I'm going to make an equivalent fraction next to 1/2. It's going to have 8 as its denominator. I multiply from 2 to 8. 2 times 4 is 8. Whatever I do to the bottom, I do to the top. 1 times 4 is 4. So now I have 4/8 plus 1/8. 4 plus 1 is 5. And my denominator 8 stays the same. And again, I know 5/8 can't be simplified because 5 is prime and it can't fit into 8. So there's not going to possibly be any common factors greater than 1. So 5/8 is already in simplest form. Now I have a mixed number. I'm going to box this off. And I'm going to solve this one right here. I have 6 3/4 plus 2 2/4. I don't have to find common denominators because they both already have 4 as their denominator. And I add my whole numbers and my fractions separately. So 6 plus 2 is 8. 3 plus 2 is 5. And my denominator 4 stays the same. Now notice 8 5/4 does need to be simplified because 5/4 is an improper fraction. I cannot leave the fraction part of my mixed number improper because this looks like it's more than 8 and less than 9 because it's 8 and then a fraction. But this is actually more than 9 because my fraction part is more than 1. So this fraction part needs to represent an amount less than 1, and then I'm going to add the whole that's in here back into my whole number. So my final answer will be 9 and a fraction. So I can't leave this the way it is right now. I have to take this fraction, since it's an improper fraction, I have to change it into a mixed number. So I divide the denominator 4 into the numerator 5. That's how you change a improper fraction into a mixed number, by dividing the denominator into the numerator. 4 into 5. 4 can fit into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. Whatever my remainder is, that's my numerator. Whatever my divisor is, that's my denominator. And it's 1 1/4. But I circled it, but I really shouldn't have because that's not my final answer. 1 1/4 is just 5/4 changed into a mixed number. Now I have to give that 5/4 back to the 8. So my actual final answer is 9 1/4 because I have to add this 1 back to the 8, and then the 1/4 part is the fraction part of my final answer, and it's 9 1/4. So it's this one right here. Okay, I'm going to box that off. I'm running out of room on this side of the page, so I'm going to turn it over. And next, I have 1 1/12 plus 3 2/12. 1 plus 3 is 4. 1 plus 2 is 3. My denominator 12 stays the same. Now this one also needs to be simplified because even though 3 is prime, it can fit evenly into 12. It's one of the factors of 12. So I know 3 has to be the GCF. So I'm going to divide my numerator and my denominator by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So now the final answer is 4 1/4 after I simplify the fraction part of my mixed number. And that's this answer choice right here. Next, I have 7/16 minus 3/16. So I'm going to box this off. 7/16 minus 3/16. Notice I didn't stack it because I already have like fractions. But if you wanted to stack it, you could just stack them all the time because that'll always work. 7 minus 3 is 4, and my denominator 16 stays the same. And 4/16 I know can be simplified because I know 4 can fit evenly into 16 since 4 times 4 is 16. So I'm going to divide my numerator and my denominator by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So 1/4 is my final answer. Next, 11/12 minus 7/12. Again, I already have common denominators here. 11/12 minus 7/12. 11 minus 7 is 4, and the denominator 12 stays the same. And I know this fraction can be simplified because I know 4 can fit evenly into 12, and I know 4 can fit evenly into itself. So 4 has to be the greatest common factor. So I divide 4 and 12 by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And the answer is 1/3. Okay, now I have a subtraction problem where the fractions have different denominators. So I'm going to stack this one. 8/9 minus 5/6 because I know I'm going to have to make these into like fractions. So I'm going to have to find the least common multiple so I can use it as a common denominator. So I'm going to count by 6s and I'm going to count by 9s until I find the smallest number that's in both lists, or until I find a number in both lists, because the first one I find will be the smallest one. So I'm going to count by 6s. 6, 12, 18. Now, once you get to a number that you know is also a multiple of the second number, most of you know 9 times 2 is 18. So there's no reason to keep going. 9, 18. And your LCM is 18. So now I'm going to make 2 new fractions to the right of my old ones. This one's going to have 18 as a denominator, but it's going to be equivalent to 5/6. This one's going to have 18 as a denominator, and it's going to be equivalent to 8/9. And I get my new numerators by multiplying from my old denominator to my new denominator. 6 times 3 is 18. And then whatever I do to the bottom, I do to the top. 5 times 3 is 15. 9 times 2 is 18. Whatever I do to the bottom, I do to the top. 8 times 2 is 16. Now I can subtract because I have like fractions, and I kind of ran out of room here, so I'm going to put my answer down here. 16 minus 15 is 1, and my denominator 18 stays the same. So that's my answer, 1/18. Right here. Somebody's car alarm's going off out there. I don't know if you can hear that or not. Okay. Here we go. Next, I have 11/12 minus 7/8. So, since 11/12 and 7/8 have different denominators, they're unlike fractions, I know I'm going to have to find common denominators, so I'm going to count by 12s and I'm going to count by 8s until I find a number that's in both lists. 12, 24. Now I know 8 times 3 is 24, so I'm going to stop right there. 8, 16, 24, and that's my LCM. So now I'm going to make 2 new fractions off to the right of my old fractions. They're both going to have 24 as a denominator, but this one's going to be equivalent to 7/8, and this one's going to be equivalent to 11/12. Now I multiply from my old denominator to my new denominator. 8 times 3 is 24. Whatever I do to the bottom, I do to the top. 7 times 3 is 21. 12 times 2 is 24. Okay. 11 times 2 is 22. Now I have 22 24ths minus 21 24ths. 22 minus 21 is 1, and my denominator 24 stays the same. So that's my final answer, 1 24th. Okay, now I just have 1, 2, 3 word problems, and we're done. We're almost finished. I'm going to box this off. Okay, Matthew read for 3/4 hour on Monday and 5/6 hour on Tuesday. How much longer did he read on Tuesday than on Monday? Now I'm going to read it again. Matthew read, and this time I would underline important information, but since I can't underline on the screen, I'm going to write it down on my scratch paper. Matthew read for 3/4 hour on Monday. That's what I would underline. And 5/6 hour on Tuesday. How much longer did he read on Tuesday than on Monday? That's what I would underline. How much longer, I'm going to shorten it, on Tuesday than Monday? That's the question. I'm trying to find out how much longer he read this day than this day. So what would I do here? I would have to do a subtraction problem, because when they say how much longer, they're saying, what's the difference? What's the difference between this fraction and this fraction? And anytime you're asked to find the difference, you know you need to subtract, because the difference is the answer to a subtraction problem. So I'm going to do 5/6 minus 3/4. I know I'm going to have to find common denominators. And so I'm going to count by 4s and I'm going to count by 6s until I get a number that's in both lists. 4, 8, 12. Most of you know 12 is a multiple of 6. 6, 12. So 12 is the LCM. So I'm going to write 12 here, write 12 here. I'm going to make two new fractions that both have 12 as their denominator. 4 times 3 is 12. 3 times 3 is 9. 6 times 2 is 12. 5 times 2 is 10. And 10 twelfths minus 9 twelfths is 1 12th. So he read for 1 12th of an hour longer on Tuesday than he read on Monday. And I'm going to box this off. Notice how much work there is on this scratch paper so far. I'm going to zoom out a little bit. This is what your scratch paper should look like when you're about to be finished with a test. Look, this entire page is filled up. This entire page is filled up. I still sometimes walk by a desk when a student is working on a test and they're almost done with it and there's like just barely anything written on their scratch paper. Your scratch paper should be filled up by the time you're done with the test. If it's not, you're not doing your best, because you're not putting down your thinking on your paper. That's something you can do to do your best. And if you're not doing all the work you can do to do the best you can do, then you're not doing your best. When Richard usually takes walks, that sentence doesn't make sense. The word when should not be there. Richard usually takes walks that are 7/10 mile long. Yesterday, he walked 1/4 mile less than usual. How far did he walk yesterday? Again, I'm going to read it a second time now. Richard usually takes walks that are 7/10 mile long. Yesterday, he walked 1/4 mile. How far did he walk yesterday? So, he worked 1/4 mile less. He usually walks this far. Yesterday, he walked 1/4 mile less than this. How far did he walk yesterday? So again, it's asking us to find the difference between this fraction and this fraction, because he walked 1/4 less yesterday than what he normally walks, which is 7/10 of a mile. So how much less is 1/4 than 7/10? That's the same thing as asking us for the difference between the two fractions. And anytime we have to find the difference, we know we subtract. So we're going to subtract 7/10 minus 1/4. And we know that, I'm going to show you a different way to find the LCM or just a common denominator. So we know about the lowest common denominator, but you can also just use the easiest common denominator. So you could use 20 here if you listed all the multiples for 10 and all the multiples for 4. The lowest common multiple would be 20. And so sometimes that one's hard to find because you have to list out multiples. But a really easy way, you don't have to use the least common multiple. You can actually use any common multiple. So sometimes the easiest way to find it is just to multiply both of your denominators together. That's called the easiest common multiple. It's just the easiest one to find. 10 times 4 is 40. 40 has to be a multiple of both numbers, because it's a multiple of 4, since 4 times 10 is 40, and it's a multiple of 10, since 10 times 4 is 40. So anytime you have a hard time finding the least common multiple, just find the easiest common multiple. Multiply both denominators together, and you've got an instant common multiple that you can use as a common denominator. 4 times 10 is 40. 1 times 10 is 10. 10 times 4 is 40. 7 times 4 is 28. And 28 minus 10 is 18. The denominator 40 stays the same. So we have 18 40ths, and that can be simplified. And, we could list all the factors of 18 and all the factors of 40, and we could find the GCF. Sometimes if you want to do it an easier way with maybe more steps, but still a little bit easier, you don't have to find the greatest common factor. You can find any common factor. So I know 18 and 40 are both even numbers, so they're definitely going to both be divisible by 2. 18 divided by 2 is 9. 40 divided by 2 is 20. And actually, I think it was the GCF, because 9 20ths is now in simplest form. So 9 20ths is the final answer, and that's this one right here. Notice I'm out of room. I have to use a completely new piece of scratch paper, and I love that. That's one of my favorite things when students are doing a test and someone raises their hand and they say, Mr. Dauber, I need a new piece of scratch paper. And I walk over there and I see both sides completely filled. That makes me happy inside when I have to give out a second piece of scratch paper to a student who's working on a test, because it lets me know they're really putting all their thinking down on paper. They're really doing their best. Okay. Excuse me. Luke was cutting boards for his treehouse. The first board he cut was 5 1/4 feet long. Notice this is a mixed number. The second board he cut was 4 3/4 feet long. How much longer was the first board than the second board? So I'm going to read that again. Luke was cutting boards for his treehouse. The first board he cut was 5 1/4 feet long. The second board he cut was 4 3/4 feet long. How much longer? How much longer was the first board than the second board? Okay, so it's asking us for the difference between these two fractions. How much longer was the first board than the second board? That's the same as saying, what's the difference between them? And again, anytime it's asking for the difference, you need to subtract, because difference is the answer to a subtraction problem. So I'm going to subtract 5 1/4 minus 4 3/4. Now this one, I have like fractions, so I don't have to find common denominators, but I can't subtract because I have to subtract my whole numbers and my fractions separately, and I can't take 3/4 from 1/4, which means I need to borrow from my whole number. I borrow from the 5, make it a 4. Now I have one whole I can add into the fraction part of this mixed number, and I do that in the form of 4/4, because remember, anytime a fraction has a numerator that's the same as its denominator, it equals 1. And 1 plus 4 is 5. My denominator 4 stays the same. Now I have 4 5/4, which means the same thing as 5 1/4, minus 4 3/4. Now I can subtract. 4 minus 4 is 0. 5 minus 3 is 2. And my denominator 4 stays the same. Now I have some simplifying to do. First of all, I know I can get rid of the 0. We don't show the 0 when the whole number is 0. It's like if somebody said, if you just had half of a pizza left, and someone said, how much pizza do you have left? You wouldn't say, I have 0 and 1/2 of a pizza. You would just say, I have a half a pizza. You wouldn't include the 0 part. So this is 2/4. I know 2 is exactly half of 4. So I already know this will simplify to 1/2. Anytime your numerator is exactly half of your denominator, the fraction simplifies to 1/2. And this was a long lesson. Sorry about how long it was, but it was important for us to go through this entire test together and really think about each question. It prepares you for the real test tomorrow. I hope you enjoyed this lesson. I hope you really paid attention and wrote everything on your scratch paper that I put on mine. And I hope you are able to really do your very best on the Chapter 9 test tomorrow. I'm very proud of all of you for how hard you are working this 5th grade year. And I will catch you next time. Signing off.